All right. Continuing solving rational equations. This note sheet will probably be a little bit easier than 8C because we can apply some stuff and sort of expedite some of these processes here. Again, rational expressions are just fractions. Okay. Now, if we have an equation where each side is a rational expression, we can cross multiply. Okay. Cross multiply. So here we can multiply 3 times 4x plus 5. And we can equal it to 9 times x plus 1. All right, then we get our equation. We get 12x plus 60. Excuse me, 12x plus 15 equals 4x plus 4. Or excuse me, 9x plus 9. I'm sorry, I can't even read my own handwriting. All right, so there, we can minus 9x to both sides, minus 15 to both sides, like we would any equation, and we end up with 3x equals negative 6. Okay, and then, solve from there. Pretty simple. You probably did it in Algebra 1. I know you probably did it in geometry, doing proportions and cross multiplying stuff as well. So that's a simple thing that we can do if we have two fractions on each side of the equal sign, cross multiply. I want to skip this question for now. I just don't like the way it's written, so we won't worry about that. You could try these three problems out right there. And then number 4, it's sort of the same deal as video game sales problem there. Asking for number of years, which year the sales are about 5.3 billion. So 5.3 billion can go right in there. Okay. So we'll have 5.3 billion over 1 equals our other fraction. Cross multiply, solve for t. All right. I'm not going to write the other fraction out, but it's going to be this big old thing there going in that spot. Okay. So you can do that. Cross multiply it out, solve for t. Now, if we have rational equations with different denominators, okay, this is where it gets a little bit more tricky. We can multiply each side by the least common denominator. Okay, so looking at this thing here, we have, a denominator of 1, a denominator x, and a denominator of x minus 3. So the least common denominator would be, again, looking at the highest factors of those is 1 of each. So it would be just x times x minus 3. Okay, so we can multiply x and x minus 3 and distribute it through both sides. Okay, so what that'll look like, if I take this side right here, each side, and multiply it by x times x minus 3. Okay, over here on the right side, we have 27 over x minus 3 times x minus 3. So the x minus 3's cancel out, and we're left with 27x. Over here, we got to distribute it through both. So we have 4 times x minus 3. So that's going to give us 4x squared minus 12x. All right. And we also have to distribute this 27 over x minus 3. So if we distribute the 27 over x minus 3, the x minus 3's cancel out, and we're left with plus 27x. Or, I'm sorry, 30 over x. I apologize for that. Long day here. So we got to distribute the 30 over x to the x times x minus 3. So the x's are going to cancel out. We're going to have 30 times x minus 3, which is going to be 30x minus 90. Okay. So that multiplies over there. All right, cleaning this up. It's a quadratic, so we can get it all the way over here, and we can combine like terms. So we have 4x squared minus 12x plus 30x is plus 18x minus 90 equals 27x. And then we can move the 27x over after that because we got to get it equal to 0. So we end up with an equation of 4x squared minus 9x minus 90 equals 0. Erase some of this here. All right, so now we have 4x squared minus 9x minus 90 equals 0. We got to factor that. Okay, we got to factor that. And so we have to multiply 4 times negative 90, which is negative 360. And we got to find two numbers that multiply to negative 360 that add the negative 9. Okay. And so going through all the factors here, you can go, negative 1 and 360 and 1 and negative 360 and 2 and negative 180 and on we go. And we should end up with 15 and negative 24. And remember, going back to our old notes from factoring here, the 15 and negative 24 is what we split that middle term up into. Okay, so I'm going to clear this out so we get a little room here. So we're going to have 4x squared plus 15x minus 24x minus 90 equal to 0. All right, and then we sort of factor that by grouping. So 4x squared plus 15x there. The only thing that pulls out of that is x. And then we get 4x plus 15. Over here, 24x and 90. The highest common factor of 24 and 90 is 6. We pull out a 6 right there, and we end up with 4x plus 15 there. So our final answer, if you remember from our factoring days, we have x minus 6 is 1 thing, and then we have to multiply it by 4x plus 15 there. So our two possible answers, we get x minus 6 equal to 0, which is x equals 6. And if 4x plus 15 equals 0, that would make x equal to negative 15 over 4. This is kind of a complicated one. If I wanted to look at one of these ones that are a little bit simpler, so let's just take a look at number 5, for instance, here. I know this one was very, very, very complex. But if we do it something simple here, so coming out here, we want to solve the equation using the least common denominator. So what we have is we have a denominator here of 2 and a denominator here of x. So what this is telling us is that we can multiply everything in the equation by the least common denominator, which is going to be 2x. So 3 times 2x is 6x there. Okay. The 2x times 7 over 2, well, the 2 and the 2 are going to cancel out. So that's going to sort of leave us with 7x. And then if we have 2x plus 3 over x, well, then the x on top and the x on the bottom are going to cancel out there. So we're going to have 2 times 3, which is 6. So we had 7x plus 6 equals 6x. We can get all this stuff over there. So we get 6 equals negative 1x, and x equals negative 6. Okay? So simple enough. You just multiply the common denominator to both sides. So go ahead and try those bad boys out. Now, pause the video. Okay, second part of 8D here. If we have a rational equation that ends up becoming a quadratic, quadratics, we know they make multiple solutions. Okay, there's usually 2 solutions. When it involves rational equations, we cannot divide by 0, obviously, meaning we may arrive at a solution that is correct mathematically, but it's incorrect in the context of a rational equation. It'll cause us to divide by 0, and these are called extraneous solutions. So an extraneous solution is mathematically, when we solve for it, it fits, but if we were to actually plug it back into the equation, it wouldn't fit. And here's sort of a example here. So if we're going to solve this one out, 6 over x minus 3 equals 8x squared over x squared minus 9 minus 4x over x plus 3. So first of all, I want to factor out the denominators, which is really just the second one. So we have 6 over x minus 3 is equal to 8x squared. Okay, x squared minus 9 is the difference of squares, so that's x plus 3 times x minus 3 minus 4x times, or 4x over x plus 3. Okay, so when we're looking at this equation here, we see the least common denominator is going to be x plus 3 times x minus 3. So we can multiply that on both sides. Okay, so we're going to multiply x plus 3 times x minus 3 to this side and to this side. Okay, so over here on the left side first, the x minus 3 here is going to cancel out with that. And so we're going to be left with 6 parentheses x plus 3 to 6x plus 18 on the left. Okay, now we get over here on the right. So we're going to have 8x squared over x plus 3 times x minus 3 times the x plus 3x minus 3. So those are going to cancel out. We're going to have 8x squared. Okay, minus. Here we have 4x over x plus 3. The x plus 3 will cancel out with that x plus 3. So we're just going to be left with 4x times x minus 3, which is minus 4x squared. And we have negative 4x minus 3, so it'll really be plus 12x. So looking at this equation here, we have a big old quadratic. We're going to set it equal to 0, so we'll minus 6. We can minus the 6x and minus the 18. All right, so we have 8x squared minus 4x squared, which is 4x squared. 12x minus 6x is 6x minus 18. So we have 4x squared plus 6x minus 18. We could end up factoring this further because we could pull a 2 out of here. And we have x squared, 2x squared plus 3x minus 9. Going to our factoring rules for this again, we're going to multiply the 2 and the negative 9 to negative 18. And we need 2 numbers that multiply to negative 18 that add to positive 3. So that's going to be 6 and negative 3. So that's how we split up our middle term. So we split up our middle term. We have 2x squared plus 6x minus 3x minus 9. And so as we clean this up, so we'll pull 2x, x plus 3, and then minus 3 times x plus 3. So this whole thing factors out to look like this, okay? We should go back to our factoring rules that we've done earlier in the year to be able to get this. However, we got to set this thing equal to 0. So when we set it equal to 0, so we get 2x minus 3 equals 0, and that's going to make x equal to 3 halves. And if we have x plus 3 equal to 0, that's going to make x equal to negative 3. Okay? So our two answers are going to be 3 halves and negative 3. Those are our two answers. However, going back to our original equation, okay? So x equals 3 halves or negative 3. We'll look at our original equation right here. With this denominator right there of x plus 3, we cannot plug in negative 3 there. Okay, because remember, negative 3 would make us divide by 0. So even though negative 3 mathematically works out, it ends up not being an answer. Okay, so we're leaving our only answer is going to be 3 halves for x. Okay, so that negative 3 right there is what we would call an extraneous solution. Okay, the negative 3 is an extraneous solution. Okay, it fits the math. The math problem gives us that as the answer, but it ends up, it's not really an answer because it would make us divide by 0, which we can't do. Okay, so here's a few more of these. Solve the equation by doing the least common denominator, check for extraneous solutions. And then we got some more down there for y'all to do as well. If you have any questions, let me know. I know this is kind of tough, but we'll take our time with it and we will work through it. So let me know if you have any questions, and you take care.